Hello, and welcome to the AI-powered TIBCO Rendezvous Graphical Monitoring demo. This brand new functionality is available in Rendezvous version 9 or later and is fully compatible with the LTS version 8.8 of the product. The installation of the graphical monitoring solution is straightforward and scripted, consisting of a few automated steps: downloading the Docker image, starting the container, and launching the web page displayed on the screen. So let's first quickly set up rendezvous monitoring by clicking on Register Transports. The setup consists of intelligent auto-discovery of the rendezvous estate by just providing a single rendezvous transport that will be used to automatically register all of the discoverable daemons deployed on the same network, including the routing daemons. There are two options for registering rendezvous: either by providing the configuration of a single transport on the network to be used to discover and register all daemons on that particular network, or by providing multiple transports across multiple networks. For convenience, if you use bulk register transports, you can either edit the example YAML file in the editor or upload a copy created offline. Let's upload an example. Examine the transport settings, validate the connectivity, and finally, register the transport. Back on the main page, the total number of discovered rendezvous daemons is displayed in the card, and the registered transport is shown in the table below. You can register additional transports at any time or delete the ones you have already registered. Let's now enter the graphical rendezvous monitoring by clicking the View Discovered Daemons button. You can view information about all discovered daemons in two formats: a table view and a map view. At the top of the page in the table view, a summary card displays the total client connections, daemon types, and rendezvous version information. Below on the page, a list of all discovered daemons and routing daemons is shown, along with the most relevant information. All columns can be sorted, and a search function lets you quickly locate any required information in the table. In the map view of the discovered daemons, multiple dimensions, including services, connected clients, subscriptions, and performance metrics, are displayed, allowing users to see the distribution of these metrics across daemons visually. Back in the table view of the discovered daemons, let's click on one of the daemons in the table and view all the monitoring data collected for that particular daemon. On the left side of the dashboard, a menu displays different views of the monitoring data, including services and clients, as well as the main dashboard, which provides consolidated monitoring metrics for the daemon that has been introspected. At the top of the page, you will find uptime, daemon details, and counts, including address, ports, and detailed configuration data. Below that section, CPU usage and memory information are displayed in dynamic graphs that show both current and historical data for the last hour or the last 24 hours. The switch for historical data is in the top right corner of the page. Further down, daemon highlights are shown, including data loss, retransmissions, and throughput performance numbers. Note that you can navigate across multiple monitoring metrics by clicking the links on each page or using the menu on the left. You can access all rendezvous services via the menu on the left. The page displays all relevant information about the services across multiple metrics. You can delve deeper into the monitoring analysis and examine detailed information for each service, including general statistics at the top of the page and multiple graphs showing retransmission rates, missed packets, and performance over periods ranging from 1 to 24 hours. At the bottom of the page, all connected clients are listed, along with their corresponding subscriptions. Clicking the client ID displays detailed monitoring metrics for the selected client, including statistics and throughput graphs. For the rendezvous client's information, you can access the monitoring by clicking on the corresponding client in the table for any particular service that is inspected, or by using the menu on the left side. This page shows a summary of all collected client metrics, including a table view with search functionality. By clicking the client ID, detailed monitoring metrics for the selected client are displayed, including all details, statistics, throughput graphs, and current subscriptions. If we now return to the table view of the discovered daemons, you will notice that the rendezvous routing daemons are also displayed in the list. If you click on one of the routing daemons, you will enter the monitoring pages for that daemon. Now, we will examine a routing daemon commonly used for the secure routing of messages between networks, locations, or regions. As you may notice, the left menu of the monitoring user interface has been updated to reflect the information available for monitoring the routing daemon, displaying networks, neighbors, and routers. The information displayed on the main dashboard, services and clients, is the same information that was previously presented. Therefore, let's focus on the additional monitoring metrics that are collected and displayed for the routing daemons. On the Networks page, the summary is displayed at the top and the configured networks are listed in the table below. For rendezvous routing daemons, several actions are available. You can add a network by using the Add Network button, and access the Delete button by clicking the three dots in the table. If you click the network name, you can view all information for that network, including subject import-export roles with corresponding actions, local routers, and subscriptions. If you click on the router, you will enter a page that displays the available information for that router, including the networks, with the available actions to add or delete networks and/or neighbors. Lastly, the neighbor page displays detailed information about the selected neighbor, including configuration, statistics, backlog information, inbound and outbound data rates, and corresponding throughput graphs for 1 or 24 hours. If we now return to the main page, you will notice a card displaying TIBCO Rendezvous AI Insights, which provides an AI-driven assistant capable of facilitating natural language conversations with the discovered rendezvous daemon estate. Before we run the demo, it is worth noting that for this functionality, we use a TIBCO-engineered, highly optimized MCP server, Model Context Protocol, for TIBCO Rendezvous. After entering the page, you will notice that several components are used to provide this functionality. At the bottom left, there is a Settings button, where you can select and configure the LLM that will be used to provide the AI-driven rendezvous insights. On the page, 3 pre-configured agents provide quick access to the deployment overview, overall health, and potential concerns related to all the discovered rendezvous daemons. In the middle of the page, you will find a prompt that can be used to ask and query any information related to TIBCO Rendezvous daemons. Options include viewing the last conversation, stopping the query if it takes a long time, and starting a new prompt or conversation. Note that the prompt design, control, and system implementation are entirely TIBCO engineered and maintained. Let's now try the Deployment Overview agent. You can see that the agent is starting to utilize the tools provided by the MCP server, displaying all available information for hosts, daemons, services, networks, routers, clients, performance, and health status. Notice the level of detail collected and displayed by the AI assistant for all rendezvous daemons, including message rates, daemon versions, routers, resource utilization, and more. The same applies to the Potential Concerns agent. The LLM will analyze the available information and display any potential concerns, which may assist users and improve various aspects of the rendezvous deployment and surrounding infrastructure. Note that for this demo, we use a test deployment of TIBCO Rendezvous with simulated network problems, solely to demonstrate multiple scenarios. To conclude this demo, Let's try asking a natural language question using the provided prompt. Show me the health status of Rendezvous for the last 3 days. You will notice that the MCP server tools are now collecting and querying historical data to display essential health information. The AI-driven assistant will collect and display essential health information for Rendezvous related to uptime and stability, performance and network, and display the areas of attention. Let's now get performance graphs for all services over the last 5 hours. The AI assistant will now collect historical information for all Rendezvous services and use a graphical visualization to display the data, allowing the user to select or deselect services shown in the graphs. Using this method, the user can drill down to investigate, for example, a particular service, the clients connected to that service, router setup and performance, or resource utilization, such as CPU and memory. This concludes the demo of TIBCO Graphical Rendezvous Monitoring with AI-driven insights. For a more detailed demonstration, discussion, and questions, please do not hesitate to contact TIBCO.